Hello folks, thanks for joining me. My name is Omar, and today I'll be talking about using Rubocop to find security bugs. So at a high level, this is what I'll be covering today. I'll start with a quick primer on static analysis in Rubocop, tie that into security, and then focus on the developer experience and why it's so important. So first, a quick introduction. I'm currently a staff security engineer at Betterment, which, by the way, we are hiring, so if any of this is interesting to you, please come talk to me afterwards. But prior to working at Betterment, I used to work at Etsy and OkCupid, where I did all sorts of security things. Also, just to note, I'm not a Ruby programmer. This is my first time writing Ruby. I much more enjoy program analysis, vulnerability research, and this just seemed like a great opportunity to learn Ruby at the same time. Cool. Static analysis. What is it? It's just a fancy computer science way of saying understanding programs without actually executing them. The opposite would be dynamic analysis, where you might, for example, use a debugger to inspect your program and get some static concrete values out of it. There's some pros and cons to using static analysis. The pros being generally that these programs are a lot easier to write and are a lot more performant. But this usually comes at the expense of false positives and coverage issues. So if you've ever actually used GitHub's source code navigation tools, you'll notice that if you can click on a method name, it'll tell you where that method is called, where that method is defined. Well, static analysis is the core of this. GitHub isn't actually executing any of this Ruby code to come to these conclusions. It's purely static. So I like to think of static analysis as kind of like the Socratic method of learning, where you ask these questions back and forth. You ask, who calls this method? What does this method return? Back and forth. These are things you ask to learn more about the program you're looking at. We do this stuff implicitly all the time when we load up source code in our text editors, when we review pull requests in GitHub, so on. But the problem with this is it's very manual, very error prone, and most importantly, it doesn't actually scale. So for the rest of this talk, I'll be focusing on performing this type of static analysis, but automatically. So to do that, we're going to start by learning more about abstract syntax trees. At a high level, abstract syntax trees, or ASTs, are the format that your compiler or your interpreter turns your code into so it's easier to operate with. Basically, computers don't have any issues with both of them, but as lowly humans, it is much easier to write programs for ASTs than it is for raw source code. So to deal with ASTs, we'll be leaning very heavily on Rubocop. So at a high level, Rubocop is used for identifying formatting issues, bugs, a lot of which that Rubocop can actually fix entirely automatically. It's an indispensable tool for anyone who works on a Ruby code base, particularly one with many people working on it at the same time. It makes it easy to enforce your style guide and keep your code base very consistent. So take this code, for example. In this case, that return statement is completely optional. However, because it is optional in a code base without Ruby, you might find this being used very inconsistently. Some developers might prefer it, some might not. So this might make code a little bit more tricky to deal with, especially for your code reviewers who maybe can't come to a conclusion about what should be used. However, by introducing Rubocop, we can actually start to take a hard stance on things like this. So here you can see Rubocop actually called me out for saying, you don't actually need this return statement, just get rid of it. This is really important because not only am I enforcing the style guide in a very consistent way, but it also saves time for the code reviewer. The reviewer doesn't need to look for these, doesn't need to leave a comment saying, hey, get rid of this. Rubocop has already done that for them. So let's just save nitpicking for the robots. Okay, so I've talked a bit about ASTs and Rubocop. You might be wondering, what do they have to do with each other? Well, pretty much everything. At the heart of just about every Rubocop is this class called node pattern, which is basically regular expressions, but for ASTs, which I know that sounds kind of scary, but if you stick with me for a few minutes, I'm hoping that it'll all make sense by the end. So take a look at this built-in Rubocop that looks for unsafe uses of the eval method. In particular, look at the def node matcher block right there in the middle. If you notice, it looks very similar to the abstract syntax tree that we generated earlier a few slides ago. This is where we tell Rubocop this is the code that we're interested in looking at. So think of def node matcher as a simple wrapper for node pattern. It makes it easy to say, I've got one line that defines what my code looks like, and Rubocop knows to look there. I like to think of it kind of as writing a program to process phone numbers in a document, where you break it up into extracting phone numbers and then processing phone numbers. Def node matcher is the one that's doing the extracting. It's very, very similar to regular expressions in that you are defining what it looks like and you are extracting the things that you're interested in. And then once you've extracted those details, you can do whatever validation you want. So you can say, cool, I know what eval methods look like. What about the eval methods am I most interested in? So let's look again at this cop from earlier. First, we start out by defining what an eval call looks like using the slightly modified abstract syntax tree. Next, when we are handed a piece of code, Rubocop will ask, does this actually look like an eval? If it doesn't, it just bails early and just keeps on moving. But if it is, then we start asking, does the one argument that this eval method take, is it a static string? If it is a static string, exit early. Because, if an eval method takes a static string, chances are it doesn't really have any vulnerabilities. However, it doesn't take a static string, that means it's taking a dynamic string, possibly taking in user input, at which point we alert the user saying, hey, this eval looks potentially unsafe, so that you and your code reviewers can tell that, hey, maybe this eval use warrants a second look. The alternative to a Rubocop like this would be to write a very long program where you might find yourself asking questions like, what methods are being called here? Do any of these methods look like an eval call? What arguments do they take, if any? And, writing a program like this isn't impossible, but it is very tedious, very error prone, and most importantly, very difficult to maintain. Cool. So you all came here for a security talk. It's only fair that I actually start talking a bit about security. So I'll be talking about anti-patterns. As software engineers, we're all very familiar with anti-patterns. These are generally things that are considered bad practice that you shouldn't do. But what makes security anti-patterns more egregious is that they are much more likely to lead to vulnerabilities. So over time, as you introduce more and more of these anti-patterns, you're much more likely to introduce a vulnerability. For further clarification, you can see my very scientific chart here, where as time goes on, you end up entering into footgun territory, as I like to call it. Basically, the more you do it, the more likely you are going to introduce a vulnerability. So that's why we call them security anti-patterns. Consider this auto.json class, for example. The interesting thing about this auto.json class is that it will pick a JSON parsing library for you automatically based on what's installed. So if you don't have the faster, more performant JSON library installed, it'll just use a default. So to do that, it relies on the eval method, basically using eval to dynamically import the JSON parsing module. However, things become a little more tricky when you want to add supports for, say, YAML. What would you do if you need to add support for YAML, or even more, if you need to let the client specify whether they're using JSON or YAML or any other serialization format? Basically, with code like this, it looks a little bit scary, but is safe, technically speaking. But what you can't do is tell what it'll look like a year from now and the security implications that come with those changes. So a more realistic example, consider this Rails controller. If you've ever worked with Rails, you've seen controllers like this a million times. But what stands out? Well, you might notice that the document object is not scoped to the current user. So whenever you are accessing this controller, the user can actually ask for any document, not just the ones it owns, but any documents it knows the IDs for. In some contexts, that might be safe, but generally speaking, that's not the behavior that you want. So to do that, the way we would fix it, typically speaking, is changing this line into something like this, basically leaning on active records relations so that the current user, it's got its own documents, and you can rely on active record to tell you, hey, this user has these documents. You don't have to do a complete search for all documents from scratch. So let's tie all of this together. We've talked about security, anti-patterns, and static analysis. Now, how can we put all these things together to actually start finding bugs? So let's focus on the document.find example from earlier. The reason why I think this is a really good candidate for security static analysis is that, structurally speaking, it's actually very simple. There's no conditionals involved, it's a single method, and it takes a single parameter. So the abstract syntax tree we'll be looking at will be very tiny. Next, the undesirable behavior is actually pretty abstract. It's not specific to document objects at all. So you might have documents, you might have messages, secrets, any model you have in your database. This anti-pattern typically will work just fine. And then the best part is remediation for these findings is actually very easy. Like you saw earlier, if you can scope it to current user, you've got your solution right there. So the general rule I like to think of is if you can write a grep command for it, or if you can find a regular expression to capture this anti-pattern, even if there are false positives, it's still a great candidate for security static analysis. I feel like just the single sentence alone makes it very easy for me to think, is this worth spending time doing static analysis on, or is this too complex that might need addressing from a different standpoint altogether? So let's build a cop to find this type of anti-pattern. Let's start with the actual anti-pattern, document.find params document ID. It's an anti-pattern because it takes user input, params document ID, and finds a document based on it without doing any authorization checks. Let's turn that into an abstract syntax tree. Now we know what that looks like, but Rubocop uses a slightly different flavor of abstract syntax tree, so let's modify it just a little bit. And then the one thing in particular that I've taken this opportunity to do is swap out document for a placeholder so that we're not just looking for document objects, but like I mentioned, this will abstract out to any active model record. So instead of document, now we can look for any other .find methods. And then we glue in some Rubocop boilerplate code, some little extra logic, and now we've got a fully functional cop. So let's walk through what we've got here. First, we start with a helpful message for the developer. We tell them, hey, model.find on user input might not be what you want to do. Realistically, we would go into a little bit more detail. This is actually pretty vague, but for the sake of the screenshot, I kept it brief. Now we've got our embedded in our Rubocop, the AST that we modified. So this will tell Rubocop, this is what an unscoped find looks like. Next, I decided to add just a little bit of extra logic so you can kind of get an understanding of what some of the capabilities are. I've decided to say only alert if the parameter name ends in _ID. So if we're looking for document.find random parameter, maybe that's okay. But typically, if the user is specifying an ID, then maybe we want to pay a bit closer attention to that. So with this little bit of logic at the end, I can actually say not just any param, but a param that ends in _ID. So with this few lines of Rubocop, I was actually able to use it to find all unscoped finds in the code base as is. But the great part is not only can we find this anti-pattern in the code base right now, we can actually prevent new instances of this anti-pattern from being introduced going forward. And the next best part of this is that the Rubocop that you saw is actually very simple. It makes it very easy to iterate on. So a next step might be to say, as a Rails programmer, params is not the only way to get user input. There's param.permit, and that might be another way that user input ends up in your code. So you might be able to very easily modify that cop that I just made to look at params.permit code as well. So the last part, but arguably the most important part, is the developer experience. I think this is often overlooked when discussing stack analysis, so I felt it to be arguably the most crucial point of this presentation, developer experience. So just as you want your apps and your websites to be easy to use, intuitive, require no extensive research, I feel the same way about developer tools, and you should too. So think of developer experience. It's a bit of a buzzwordy term nowadays, but developer experience is basically user experience where the user is a developer and the product is a developer tool. So these are things that you want to keep in mind when you make developer tools. And lastly, what we want to do is make sure that we keep our developers safe, but not sacrifice productivity in the process. If developers realize that they are operating at half capacity because they're wrestling with security tools the whole time, chances are they're not going to want anything to do with you or your team. So I find myself asking these questions a lot. I'm not the developer here. I'm just the maintainer of this tool. I just wrote this tool, so I want to keep in mind the perspective of the developers who work with my tools every day. So I find myself asking these questions to kind of keep things in perspective. Firstly, I need to focus on the offenses that Rubocop raises. Are my developers equipped to deal with these? If they are working on a pull request that needs to go out the next day, will this Rubocop finding delay that deploy by a day, an hour, 5 minutes? These are questions that you need to ask. Next, how easy are these tools to configure? A lot of security stack analysis tools, and stack analysis tools in particular, or in general rather, are very difficult to use. Some old school security stack analysis tools, very enterprise focused, have literally entire teams dedicated to them. Unfortunately, I can't expect that from my colleagues. I don't think it's fair to expect that from them. So one thing that I focus on a lot is making sure that anyone who wants to adopt these tools has a very easy time doing so. And then next and last is, what burden are we adding? When we add stack analysis tools to an already existing and pretty long and hefty testing pipeline, I want to make sure that if there are false positives, that it doesn't take an hour to triage every single one of them. So these are things that you want to consider when you introduce tools, not just security tools, but tools in general, the burden that you add to a developer's lifecycle. So dealing with offenses, basically a developer should be able to deal with offenses without having to consult a subject matter expert every single time. If they find themselves needing to open a ticket with security or get on a Zoom call with you every single time, they're going to start to tune these things out. That's not fair to them, and ultimately that's not fair to anybody involved. Even the security team that made these tools, that's not fair to them. So the harder it is to use these tools, the less likely they'll actually want to use them. Also, I've seen a lot of security teams take kind of like an RTFM approach to these tools, where basically they'll say, we did the hard part in identifying these bugs. It's on you to figure out why these bugs matter. I don't think that really makes sense. That in the long run, I've seen personally actually causes a lot of problems. When you have engineers who have been told that there are vulnerabilities in their code, but not told what that actually means, they'll think, oh, this is just a false positive. I'll tune it out, I'll push it to production, and I'm done for the day. You can't really be doing that. So one way we've addressed that is by trying to add inline remediation advice as much as we can. So our production version of these Rubocops will actually tell you hey, this is what you're doing, this is what the code might actually need to look like. And instead of having a massive message, we actually link out to some documentation that goes into a little bit more detail about what remediation could look like. So another key detail is to keep things simple. As software engineers, it's very tempting to have all sorts of configuration options. You might want to have like a sliding scale for how sensitive the tool is to finding vulnerabilities, what arguments it looks at. But ultimately, as the developer of this tool, you are the subject matter expert, and it's fair for you to be opinionated. In fact, I think you should be opinionated when you deploy these tools. As a subject matter expert, you are the one that people come to get advice. So to save them time, be opinionated, embed those opinions into the tools you make. And next, I found that the empathetic approach actually ended up being the most productive approach, where we could have done the security stack analysis in any number of ways. We could have used a new tool, we could have purchased a vendor, but we found that all of our engineers actually are very familiar with Rubocop, so it made sense for us to stick with that. Prior to this work, we actually did use several vendors that attempted to do this, but we found it to be very difficult because these developers needed to read more documentation, install vendor tools, talk to vendors, and figure out why vulnerabilities are being surfaced when they maybe didn't need to be. But by sticking with Rubocop, it was a little bit more effort on the security team's part, but it pays off a lot in the long run when you stick with the tools that the developers are already comfortable with. Basically, if you meet the people where they're at, you'll have a lot more luck. And lastly, if your tools all look like this, no one's going to like you. No one's going to want to talk to you. No one's going to want to look at this. They're just going to close their laptops and walk out of their office. Just don't do this. So next up, minimizing toil. I feel like this is also kind of peripherally touched when people talk about stack analysis, but people don't go into enough detail. So maintaining a high signals to noise ratio is crucial. As a developer, you might say, oh, if I add this one extra line to my tool, I can surface 2 more edge case vulnerabilities. And as a security person, I'd be like, cool, those are very important things to surface. But if those 2 security vulnerabilities are real but come at the expense of 50 false positives, I don't know if in good faith I can condone that type of finding, because ultimately that's 50 false positives that an engineer has to triage. That might take a lot of time and ultimately reduce the trust in your tools. And when you reduce trust in your security team and their tools, you end up weakening security overall in the long run. There's also other ways of addressing this. So instead of saying, oh, these 2 edge case vulnerabilities, we need to find them, you might be able to address those vulnerabilities and address that gap in other ways. For example, developer training or code reviews, basically non-technical approaches to addressing technical problems. We found that developer trainings can actually be very important, and often sometimes you can't solve everything with a technical solution. So closing, just a few key thoughts I think are the most important thing. Writing cops for security vulnerabilities is a lot easier than you might think. I'm a security engineer, but not a Ruby programmer. A lot of you are not security engineers, but you don't have to be. I took a single line anti-pattern and managed to turn it into a maybe 20-line Rubocop to look for that anti-pattern. If you've ever spent time grepping for a vulnerability, for example, you're reading the news and you find this new vulnerability, or you're doing a code review and you find something, oh, hey, this code doesn't smell right, chances are you can turn that into a Rubocop yourself. Next up is prioritize developer experience as early as you can and as much as you can. The developer experience is key because ultimately the developers are your customers and they are responsible for the success to you and the company. So prioritize this as much as possible. And next up, as maintainer of these tools, you should be empowered to be as opinionated as possible. You are the expert here, and so you should feel very comfortable in making decisions on behalf of your developers, on behalf of your team, your company. So this saves you time, this saves everybody time. So wherever you can embed your opinions, please do so. You will be helping out everybody. And next up, here's just some quick resources. We've open sourced a lot of our Rubocops, a lot of which are security Rubocops. I have some more production-friendly version of the cops that I walk through here, but you can take a look at these, see if any of these make sense for your code bases. I've also included a link to a blog post that Firefox wrote about, or rather Mozilla wrote about Firefox and thread sanitizer. It focuses a lot on dynamic analysis, but I found that their approach to developer experience was pretty universal, and I learned a lot from reading this blog post, despite it being C++ and not Ruby related. Cool. Thank you all for coming. This is my contact information. Like I said, we are hiring, so please feel free to come talk to me or anyone else in the Betterment t-shirt. You can also email me, click that link, I don't know, from the slides that might go out later. At any point, just, I don't know, flag me down. Cool, that's about it.